Today I'm going to show you how we can change a quadratic equation from standard form to vertex form using the process called completing the square. I have the equation y equals x squared plus 6x minus 2. This is not a factorable equation, so I can't factor it using my regular area model and my diamond. So instead I'm going to complete the square. First thing that I do is I make an area model, but this time, rather than using a rectangle like we've done before, I'm going to force it to be a square. So what I'm going to do is I'm just going to take these two terms, my x squared and my 6x, and I am going to put those two into my area model. Since I'm forcing it to be a square, that means that these 6x's have to be split evenly between these two boxes on my diagonal. So I'm going to have 3x here and 3x here, because 3 and 3 is 6 when I add them together. This extra, my constant out on the side, I'm going to put that outside of my square. The next thing I need to do is I need to figure out what would this be to complete this square, hence the phrase completing the square. So since this is 3 by 3, that means that I would have to have 9 extra units in here. But since this is an equation, I can't just add something to it without balancing it to keep the equation true and keep it balanced. So if I add 9 extra units here, I have to subtract 9 units outside of my box. I'm subtracting it since they're on the same side of the equal sign. I could add 9 to the left side of my equation as well, but for this it doesn't make a whole lot of sense to have y plus 9 over here. So instead I'm going to keep it balanced by subtracting 9. Because if I add 9 and then take them away immediately, I'm really just adding 0 and I'm not changing the value of my equation at all. Now I am going to work the outside of the area model to get the dimensions, the length and the width. So since I've got x squared here, I would have x and x. This would be 3 and that would be 3. And now, since I have x plus 3 times x plus 3, that is the same as saying x plus 3 squared. So I'm going to do that, x plus 3 squared. I still have minus 2 minus 9 outside of my area model, so I can't just ignore those. I need to include those in my final equation. So if I have minus 2 minus 9, that gives me minus 11. So now my final equation is y equals x plus 3 squared minus 11. And this is your equation in vertex form. Does anything change if my equation has negative x's instead of positive x's? Well, let's take a look at this one. So I'm going to take my x squared and my x terms, and I'm going to create a square with those. I take the x squared and I put it down here. I split up these negative 8x's evenly amongst this diagonal. Since they're negative 8, I'm going to have negative 4x and negative 4x. And then I still have this plus 9 that I just add on to the outside of my area model. Now, if I work the outside here, I've got x and x and negative 4 and negative 4. And to fill in this empty space here, I would have to do negative 4 times negative 4, which is 16. So I have to add 16 here. But I can't just add 16 to my equation without balancing it. So if I add 16 inside the model, I'm going to subtract 16 on the same side of my equal sign outside my model. Now I can rewrite my equation. Y equals x minus 4 squared, since my length and my width are identical, that's what makes it a square. And then if I have plus 9 minus 16, that gives me minus 7. And there is my equation written in vertex form.